hand, otherwise I'm giving it to you. What was the rule that you guys found? What was the rule that you guys found from a while ago? Wait a minute, pause. I don't even want to know the rule per se. I want to know what looks or what seems to happen in almost all of the derivative rules. My advice, start there and go backwards. In the inverse trig. In the inverse trig derivative rules, what seems to happen in all of them? What do they all have? Because you guys hopefully found them all, right?
1 over.
They're used, but 1 over in almost all of them. Maybe u prime over if you want to think about it that way. But 1 over times u prime or u over. And then there's a lot of square roots in everybody but tan and cosine, because tan and cosine don't have square roots. So there's a 1 over. There are square roots in most of them, but then in the square roots, there are squares, right?
Yes.
Okay. So just trying to kind of think about some common characteristics in inverse trig. You guys went and found those rules. That's perfect, because we need to go backwards from those rules starting today. In just a little bit after we go over homework. So for this guy, okay. What was the derivative rule for secant of u?
1 negative 1.
Okay. Nope. It's a secant, not a cosecant. 1 over.
Oh, shoot. Joe Mama.
Absolute value of times the square root of. And then technically times u prime, right? Are we good? So then we have 1 over. Why am I not going to put absolute value bars when I go to write x squared plus 1?
Because they'll always be positive.
But why do I have to put parentheses? Yeah, I need it to be clear. And I have the square root of u squared. That's x squared plus 1 squared, right? Minus 1 times u prime, which is 2x. Did I want you to, that's technically dy dx, did I want you to stop there?
No.
No, because don't we have some at least foiling and like combining and putting the 2x up top to do? So then if we FOIL, we get what? X to the 4th plus 2x squared plus 1 minus 1? Oh, that goes away. So we end up with, I'm going to put a little more room, put that 2x on top because he's technically over 1. Fractions multiply across. And so I end up with 2x all over x squared plus 1 times the square root of x to the 4th plus 2x squared. So what did I mean when I said I wanted you to turn this derivative into an integration? I don't want you to antiderive it per se. Any derivative rule can be rewritten as an integration. What would I put inside the integral? Yeah. This guy, right? You put in the integrand is the derivative of somebody, and that somebody is the antiderivative. So we're going backwards, taking the answer. If it helps, you can always think of, we're moving the dx to the other side, and then we're integrating.
Wait a minute, I think.
But what does this become? What was at the beginning? We have to go backwards from that
T-proof.
to get that? Well, we could do a T-proof, but we just showed how this is that, right? So the question is, actually, you know what? I totally did this with my pre-cal honors kids yesterday. It's not due Monday because there's a holiday Monday. We have a 3-day weekend. Praise Jesus, we all need it.
Yeah, me too.
Okay, we're going back, especially our athletes and all of our kids that have been excelling every day at lunch for the pop-up shop. But going back, so that's due Tuesday. But what section is honors pre-cal in?
Partial fraction.
Partial fraction. Partial fraction. Partial fractions would give you something
We have to split it up.
where it was all nice and put together and you needed to split it apart, right? I was actually trying to think of what their problem was yesterday. But I used the T-proof analogy and it actually made a lot of sense because I was like, hey, can you show me how? And it was something like, I don't remember. Minus 3. No. Minus 2x minus 3, something like that. And I had the partial fractions over here with an x minus 3, and then, oops, maybe it was a 1x, I don't remember. It is 2. It is 2. Okay, I was right. La. And then I think it was like a 1 and a negative 2, so then we could figure out actually what should be on top. I don't know, I forget. But I think it was like x plus 1 maybe? No, x minus 1? I don't remember. But anyway, whatever it was, I went ahead and I said, hey, what if you were to make this a t? If you were to make this a t, which side would you choose? Which side could you make look like the other? And from their past experience, what side did all of them choose? Having never seen that section before. Yeah, no, they've never seen partial fractions. They've never had to split something up. So they were all like, oh, whatever, get common denominators, no big deal. We did that with trig. Common denominators, multiply top and bottom, let's go. And they made it match. If I made the example right. Did they check to see if okay? That might not be. Anyway, so then coming back, I was like, great, I'm glad that you can go forward this way, but here's the actual goal of the section is also to be able to go backwards. How does that sound like what I've just given to you? What if we were to make a t-proof? Could you take the derivative of this side and make it match with the integral? Yes, you've already done that. The question is, in this section, how do you go the other direction? Not how do you take a derivative. That was last semester. You found it a long time ago in your notes. Forever card number 19. We're on forever card number 40.
Oh.
And it's about to be 41. After that, even getting better. How do we go this way?
I was feeling like he just like,
okay. Let's pretend you didn't know that. Who would be your you?
I want to.
What would you think? Would you think the whole thing?
No.
Hopefully not, because that'd be a product rule. That's going to be a disgusting u prime for my du. Would you think the underneath inside the square root part?
Yes.
I would think that.
Right? I think I would too. Right? Because they're like, okay, it's down and it's in, and it's just like, but what's the problem? 4x cubed. What am I doing? Oh, u prime for du. 4x cubed plus 4x. It's nowhere, and I have x's everywhere.
But there's a choice on the top. That's why.
But check it.
The other way.
Check it.
I see it, Adam. I see it.
Check it.
This is blasphemy.
I completed the square! And look! It's a u and a u squared minus 1. Start speaking! Do we have to maybe review some basic algebra? Yes. Otherwise, you're not going to want to go make a u out of anything that you see right there. Except maybe this one, and hope that you're kind of right. U is x squared plus 1, du is 2x, but what am I doing? You complete the square and say, oh, look, he's right there. Anyway, today's going to be a party, but before we go have a party with completing the square, let's go back and say, hold on, pause. Can we just talk about LNs for a bit?
Yeah.
Let's review where we've been, something that we kind of are familiar with, but still got tricky at times, but still was easy at times. Were you guys okay on number 2? Did you pull out the 10 and see the 1 over x and go to ln of absolute value of x? Were you more amazing than the answer key and went even farther and simplified?
That with the 10.
Yeah.
And get rid of the odds, right?
Were you more amazing than the answer key, being like, I don't know what the AP is going to throw at me?
So much.
Did you beat CalcAB?
Couldn't see it.
Number 18, did you do division? And when you did division, were you able to say boom, boom, boom? All right, let's use an ln. Were you super, super careful and still did your u sub for this one in particular? Because technically we need to be really careful whenever we have a u that's not just an x, which is why I really wish there was a 2 right there. But you guys were lucky even if you ignored the u, because this time it was a 1 dx, which didn't throw anything off, but next time maybe not so much. Kyle, what was your question? Don't make it the 115th power. Kyle, sorry, what was your question?
Nothing. I'm really helping.
Okay. Wait. But pause. We just talked about it. Did you divide? Did you get x squared minus
Very
5x
wrong.
plus
No.
19 reminder for me?
I had wrong.
Okay, what'd you get wrong? Because
I
division is what we did yesterday.
Yes.
So what did you have written down after you
I
divided?
think my math was wrong.
Yeah, that's
I divided wrong.
Tell me what
I
you got.
did x minus 1.
Not x squared any? The reason why I'm a little confused is because x plus 5 goes into x cubed, x squared times. So you should have at least had an x squared. Now we also have minus 6x minus 20. Maybe you wrote down the wrong problem. Double check your problem. Because I think you would have known x squared. I think you would have known x squared. And
I think I
then,
actually put x squared instead of x cubed.
oh, that would do it. That would throw you off. That would do it. That would throw you off.
Yeah, okay, that means okay. Yeah. That'll do it.
Okay. Number 26. Somebody was working on this one after school. This one it was like, yay, divide. Everything's nicer. This one, there's an x squared over an x cubed. I can't divide because it's not improper. I have a squared over a cube. So therefore, it's not top heavy. It's not greater than or equal to. The numerator's not greater than or equal to the denominator. So, well, what else can I do? Well, I guess I can multiply it. Although that's confusing. Is there a squared somewhere? Is the answer key wrong? Was there a squared?
Nope.
Oh, CalcChat. They're making it look perfect, those silly CalcChat people. Hold on, we wouldn't have done that crazy plus 1, minus 1. We would have just distributed. CalcChat, trying to make it look perfect. Instead of multiplying and dividing at the same time, they're adding and subtracting at the same time. Totally valid, creative way of making it look perfect. We're like, whatever. Your u should have been x minus 1, and your du could have been dx. So we could have plugged in and gotten x squared minus 2x all over u cubed du. What you guys do next? Yeah, integration on steroids. Because I have an x, and so let's go get rid of that x by figuring out that x is u plus 1. And then we got to go plug it in and plug it in. So then we end up with, hopefully, the integral of u plus 1 quantity squared, which is u squared plus 2u plus 1 minus 2 times u minus 2 times 1 all over u cubed. Can we combine a little bit? Oh, those go away. Do those go away?
Yeah.
Nice. And then 1 minus 2 is negative 1, so I have u squared minus 1. Can I do both of them over u cubed? And all of a sudden, oh my goodness, I am so close to being able to anti-derive. Which is how I get ln of u minus, well, I have to add 1, so u to the negative 2 over negative 2 minus a negative 1/2 is plus 1/2 times u to the negative 2 plus 1/2, who is u to the negative 2 over u squared. Ln of u plus u. Dun, 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 dun. That's the way I would have done it. I realized CalcChat was a little different because they were like, ooh, if I add 1 and subtract 1, if I complete the square, little stinkers. Oh man, that made life a lot easier if you had just completed the square. But that's okay. Our way works too. Number 32, number 56. Let me try to get in so you guys can see those. 32 was a plug-in chug, but your u was 5 theta, which is why there has to be a 1/5. And the negative came from the derivative rule that the integral of tangent is negative ln of cosine of u. But your du would have gotten that 1/5. Number 56, did you guys divide? You didn't have to, but you could have, because the degree of the top was tied with the bottom. You could have divided. You would have gotten 1 with a remainder, because x goes into x 1 time. You would have gotten 1 with the remainder, which made it easier to solve, but you could have also done it with u7 integration on crack. That would have also worked. We have number 106 matching with A, and then we have 108 that I need to zoom in on, because man, he's tiny. I don't know why.
My goodness. Cal doesn't do that.
But anyway, sorry, coming back. 106 is A. Number 56 is 1 minus 2 ln of 2. Oh my goodness, were you guys better than the answer key again?
Yes.
How would you have rewritten this?
1 minus ln 2.
Got him.
That's Chief.
All right. Chief, Kansas City. They won the Super Bowl. I don't want my picture. That's not helpful. Let's go away. Thanks. Okay, let's zoom in because this one's a little bit zoomed out. What if we were to go to like 150-ish? 108A, the tangent line. Here's one version of it. But you guys can see your y minus y1 equals m times x minus x1. Remember, your y1, you would have had to have plugged in your pi over 6 to your original. And then your m, you would have had to plug in your pi over 6 to your derivative. So you can check your derivative. Did you get it right? Did you plug in and do the unit circle? You could have simplified it, or you could have just left it right there. I would have boxed it and been done. Letter B, there's that tangent line at the very top. Letter B says to write an integral expression, which is actually on your last test. You guys will hopefully get back tomorrow. Because the area of the region is found by an integral. No, rectangles and trapezoids. No, that was approximating. Integrals do it exactly. So now that we know how to use an integral, we can just say the area is the integral. And in some AP questions, if you're allowed to use your calculator, you just throw that puppy in and get a decimal. If you're allowed to use your calculator. And then letter C, average value. Didn't you guys use 1 over b minus a, the integral from a to b of f of x dx? Did you cheat and just plug it in? Okay, well, that works. It was a decimal. So you could have just plugged it in your calculator. That wasn't cheating. That was using your resources. However, if you had been snazzy and anti-derived it, you could have done this by hand. It just would have been a little bit messy. Although, here's something interesting. Can I just do a spotlight on the LNs for a second? Is that okay?
They look really similar.
Already been anti-derived, already been f of b minus f of a. You get this expression. The AP wouldn't have left it like that because of log properties. Can't the 1/2 come up as a power of 6? And isn't a 1/2 power a square root? But isn't there also a quotient property of LNs? And isn't there, no, there's absolutely nothing else you can do because the 6 is under the square root and the 3 is not. You're done. But we could rewrite that ln in something much simpler. This is way more AP approved. That one.
It's CalcAB approved.
Huh? It's one single ln as opposed to an extended ln. This one is expanded. This one is condensed, going back to pre-cal lingo. With that, I'm pretty sure that would have been the last one because it's pretty messy and gross. Guys, I would love to get into inverse trig, and I think we have time, but let's say like 3, 4, 5 minutes. Anything from homework you want me to slow down on or do it my way, show it my way. Yeah. 29? No, that's okay. Remember, we know that CalcChat does things weird, right? But you were looking at, is it not a video though, right, Kathleen? It's just a CalcChat written out one. Anything else besides 29? Huh? Anything else besides 29? Okay. Please realize if I stop taking homework questions, it's like, well, you guys have to ask for it and self-advocate. So if you're not self-advocating, it's okay. Just please realize I know that everyone doesn't perfectly get this section because it's a hard section. I just need you to, if you don't feel comfortable asking in class, come find me another time, yeah?
Yes.
Okay. My people that come ask me questions, do I treat you like you're dumb?
No.
Never. Why? Because I know it's hard. For some of you, it's easier than others, but there is no judgment for you coming and asking me how to do a problem, ever. Or even how to do an entire concept, how to do an entire section. What's the one time I'll shame you? But it's for your own good.
+8.
If it's the night before the test and you come saying, I don't know the entire chapter, that's when I'm like, oh, wait a minute. Hold on. We should have dealt with this a lot earlier. So that's not me shaming you that you don't get it. That's more me just pointing out the truth that you made a really unwise decision as to how long you waited. Does that make sense? That's the only time I will challenge you. Otherwise, I'll work with you. Okay? I'm not saying I won't work with you even then. It just there's only so much I can do if it's the day before the test or the morning of the test. And you're like, well, I'm going to fail because I don't get it. And I'm like, well, it's kind of your own fault because you should have reached out for help. I know it's a hard truth, but some of you are about to move away to college.
Yeah.
And you have to make good, wise decisions in order to succeed. I know you are.
Doing the work.
Wait, Kyle, what does that mean? Can you just take I'm going to pause the video just for a second. Oh, yeah, we are. Kathleen, what'd you try? Perfect. Yeah, no, you're totally right. So if you use the denominator, square root of x minus 3, just a quick heads up, this is a lot like the one we did yesterday with a nasty square root of 2x in the denominator. This is actually kind of why we did that example. When you did du, I'm really hoping that eventually after rewriting, you got this. Good? And then when you went to solve for dx, you would have gotten this. If you did it my way, where you're like, whatever, I have a dx, go plug it in. My u, where did it come from? Okay, let me go plug it in. So then I have my over u, then I have my 2 root x du, and I have a root x. Now I'm going to purposely go up, take time, even though my smartboard is super annoying, to go get a blue pen and double underline this. Why? I can't proceed forward until I have an entire integral in terms of u. I'm stuck. I'm partway there, but I have extra. This is the crazy integration on crack, integration on steroids. We want to go forward. The integration is not what's crazy. It's actually the substitution. We plugged in u, we plugged in dx with du. We have extra. Go back and do more. Do more. Get this by itself. Add the 3. Now I have something. I don't even need to get x by itself, Kathleen. I just need to, exactly what I need. I'm just going to put it twice. So now all of a sudden, let's go back to red and say, oh, that's my substitution. I'm going to go ahead and plug in u plus 3. Well, actually, there's 2 of them. So I can actually do u plus 3 squared all over u to u. And now we're at a point where you're just going to FOIL, and you're just going to go ahead and divide everything by u, simplify your powers. Oh, you did?
I really put u instead of x, like when solving for u.
Oh, bummer. Okay, yeah, so then you would have, that would have thrown you off. That's sorry. You probably still would have legally been able to do something, it just was the wrong one. Okay. Yeah, anything else you guys want to see? Going once, going twice? Okay, I'm moving away just because no one's self-advocating, but I'm still available for help, and I would love to get a whiteboard and try to help you out. Either with making it match or with even starting a problem. Some of you are stuck on the starting because you need to come in. You need to come in, or you need to find a calculus buddy if you don't feel comfortable working with me. I really try to be approachable, but I know the subject that I teach is hard, and so some of you are just naturally intimidated. Maybe it's because of your work ethic. Maybe it's because you just have fallen behind, but please, please, please. It's much better to ask for help today than to know that it's too late the night before a test. Even if it has been too late on other tests in the past. We're still wanting to help you succeed as best you can on the overall AP. Nothing is expired until the night before the AP. At that point, I'm like, close the books, close the credit cards, get sleep, wake up in the morning, come get breakfast from me, and then do the best you can. The night before the AP is when it's like, well, at this point, it's time to stop. But we're not there. We're not there yet. Quick reminder, some of you guys were absent yesterday. Remember, I am having that CalcAB date up until April 4th. There is one makeup day. It's after spring break, the Wednesday after spring break, when Austria people are gone from 3 to 7. Those are the 2 options to take your final exam. If you can't make either one, you get a 0 on your final exam. Unless you talk to me very early and maybe get me to move that retake or that makeup day. But I cannot have the makeup day be before this date because something might happen that morning of. And if they don't make it, I need to have a time for them to retake it. And guys, this is 4 hours out of my life. And grading is a beast if I don't, oh yeah, thanks. Grading is a beast if I don't have it all at once, so I cannot do more makeup days than the actual time and one makeup time. Hence why I have to do it after spring break, because this is the Saturday that starts spring break. So plan ahead, talk to me. If you see a dilemma or if you see a scheduling conflict, I'm already telling you, I know Austria is a scheduling conflict, but you need to make it to the Saturday one. We are in section 4.7. You guys can see at the front of the room. Inverse trig. Integration rules for inverse trig. I'm just going to put integration up here if you guys don't mind. Inverse trig. You guys already told me that all the inverse trig derivatives, which are going to be showing up in integrals in some form, but maybe some simplified form, have 1 overs, or maybe u prime overs. Ooh, have 1 overs, or maybe u prime overs. Some sort of expression with an x squared or a u squared minus 1 or a 1 minus u squared or a 1 plus u squared or a u squared plus 1. You have to have that in your mind in order to be able to think, who should you be? Now here's the crazy thing. Some of you might go thinking, oh, okay, this is inverse trig. Well, this is actually an old school problem I could have shown up 2 sections ago, because who would you guys choose to be your u? 1 minus 4x squared. Because who would your du be? Come on, you guys know negative 8x dx, right? Do you see how CalcChat would be pretty happy besides the negative 8? Because they're like, hey, it's perfectly there, right? Yeah. Okay, so that's good. This works. Having u be that entire weight. Why didn't I choose the square root? Oh, it can just be a power. Yeah, it's something outside of the u. So this is one of those like, hey, u, and you would have been perfectly good, because look at that x dx. I'm going to be great when I solve for dx, and I go to plug in, and I take the u from where I found him. And I would end up with u with a square root and x with a du over a negative 8x. The x's are going to reduce. Ooh, is it a negative 8 or a negative 1/8? 1/8. I can pull out that constant due to the constant multiple property. I can make my u to the negative 1/2 power du. That should be all you need to now realize it goes to the power rule of x to the n plus 1 over n plus 1 plus c. Except this will just be a u to the n plus 1 over n plus 1 plus c, all times negative 1/8.
2/3.
Not 2/3. Careful, careful. If I'm adding 2 over 2 to a negative 1/2, it's just going to be 1/2. Okay. Now, how is this one different? What if I did the exact same thing?
Well, then you'd be left with the 18x on the denominator.
Now, have we had things be weird where we had extra x's show up? Yes. And I could show you that, and I could show you me doing it wrong. I could show you that. But my guess is, remember how it was messy, you guys come up with Smartboard? My guess is you're probably going to make that mistake at least once in your homework attempts. And so you'll see it go wrong. My question is, does this look like any of the inverse trig rules?
Yes.
Did I just have you find them a second ago in your notes when you're forever cards? This looks an awful lot like sine inverse.
Yeah, it does.
Because sine inverse says 1 over the square root of 1 minus u squared. So guess what? U is equal to 3x. Du is equal to 3dx. Don't know why I did those things fine. Dx is equal to du over 3. So when I go to plug in, wait a minute, from where I got it from, that's weird. It's going to be a 1 minus u squared. Oh, that's right. That's exactly what I need if I know my derivative rules. I can pull out my 1/3 and I can say, ooh, that's exactly arc sine of u, who is?
It's what? Ooh.
Any oop? Any oop?
Oh. Out.
I know, that's the old one.
Okay, now keep it
I have
right.
Joe making old jokes every day. Hey, Joe. All right, moving on. We might, and we probably will, but let's not. Let's go here.
Number 41.
We might, but for right now. Whoa! Whoa! What's going on? There are A's! Well, long story short, and I probably will tomorrow show you one with an A. You won't always see nice 1 minus u squared minus 1, 1 plus u squared. You're not going to always see the nice 1. So if you saw something like 4 minus u squared, or u squared minus 4, or 4 plus u squared, you can actually still go straight to an inverse trig without having to do some crazy simplifying to make it a 1. So it saves us a lot of time and a lot of work. But I will show tomorrow. How technically, if there is an a squared, we make it a 1 minus, which ends up ultimately getting us this. It's messy. It's a lot easier to memorize. But do you guys see the 1/overs? Do you see the square roots? Do you see the non-square root? Do you see the u primes are really in the du's, and so it lets us go back to the inverse trig? Wait, what's missing? Where's arc cosine, and arc cosecant, and arc cotangent? Wait,
Negative.
they were the same thing, but with the negative. And if there's a negative, can't we just pull it out and put it with the arc sine? Could we go to an arc cosine with a negative? Yeah, I guess we could. But we'll just go to an arc sine. This might seem really crazy to you unless you remember that arc sine is really just representative of an angle where something is true. Arc cosine with a negative will actually get us back to the exact same location, even though it looks differently. Arc trig is a little funny. That way. Kiddos, we're going to end here today because we've had a lot of discussion, a lot of practice, a lot of examples. But for some of you, all you need is the new rules and then say, oh, new rules. Okay, let's go tackle the ones that look like this. Bye, guys. Homework will be due on Tuesday.